Hello, class 11th kinematics. Well, we have already covered some of the basic concepts in detail in previous video. Here I will give another brief summary of some of the basic concepts in this kinematics. State of rest, state of motion. So a body is said to be in the state of rest if it is not changing its position with respect to a reference point. We have already discussed about reference point. And if it is changing its position with respect to a reference point, then it is said to be in the state of motion. Distance is the length of the path traveled by the body, and displacement is the straight line separation between its initial and final position. So then speed is the distance traveled by a body uh, per unit time, and velocity displacement covered by a body per unit time. Then next topic is acceleration. If velocity is changing, then there is a measure of how velocity is changing, and we call it acceleration. So acceleration is the rate of change of velocity, and retardation is just the negative acceleration. Generally, retardation is used uh, in such cases where velocity is decreasing, but acceleration term can be widely used. Retardation terms just indicates that if retardation term is given in the question, we have to consider it as negative acceleration. Nothing more than that, nothing less than that. Okay, so here just I want to conclude that there can never be a kind of absolute state of rest or absolute state of motion, because they are relative terms. They are with respect to a reference point only. Then there comes distance and displacement, so they are not dependent upon how the body is moving. If body is moving in this way, if we are interested to find length of the path, then that will be distance, and if we are interested in just the end point and the straight line separation between them, then that is displacement. uh, in this case it looks like what I'm saying, both things are same. No, it's not like that, because if path is irregular, then distance is different and displacement is also different. So but remember one thing, that if path is straight, it doesn't mean that distance is equal to displacement. Only the magnitude of distance is equal to displacement, but because displacement can be negative also. Same for speed and velocity, and uh, for whole journey for a longer period of time, we consider average speed or average velocity, and for short duration of time, for a particular moment, particular instant, we consider instantaneous speed and instantaneous velocity. Now what is this acceleration? Let's uh, study it uh, quantitatively. So acceleration is actually rate of change of velocity. That's all. So its SI unit is meter per second square, and its dimension is LT minus 2. That's all. Uh, in some cases, it is mentioned as V minus U by T A equal to. So this is also, but we'll consider this delta V by delta T. And as I have introduced in my previous video a new kind of mathematics that is called calculus, and in calculus there was a differentiation. So if delta T is tending towards 0, I mean for a particular moment, if we want to find acceleration at a particular moment, then we have to reduce this delta t to very small values so that we can measure acceleration at that particular point. Then a will be replaced by dv by dt, and this is not just an ordinary mathematic, it follows certain rules. What are the rules? dt to the power n by dt is n t to the power n minus 1, d for some constant by dt is 0, and d for some constant times t to the power n by dt is equal to cn t to the power n minus 1. If constant is alone, then it will vanish, and it's totally accepted. dv by dt, if velocity is constant, then acceleration will be 0. Totally understood. Okay, so uh, as I introduced uh, differentiation, so now I'm going to introduce a new kind of mathematics. But before that, let's take a look to graphical representation of motion, because from there I'm going to build a new concept. I'm going to introduce a new type of mathematics. As there was differentiation, so there will be another type of calculus which is called integration. But before that, let's discuss about graphical representation of motion. So first I'm drawing ST graph, displacement time graph. What is the difference between distance time graph and displacement time graph? So distance time graph, see, if this is S, this is T, and I'm drawing like this, means position displacement is decreasing. So that will never happen in the case of distance. So this is completely displacement time graph. But if the graph is going like this, always increasing, then this can be displacement time graph, but this can be distance time graph as well. And if this is going to negative, then definitely it is displacement time graph. So remember this thing, that the distance time graph will never fall down, and it will never be having negative value. There is a tricky question. Can this graph be possible? I mean, this graph be possible? And which type of graph is this? So of course it is possible. Someone will say that how can time be negative? So see, I'm choosing this moment as 0 reference time. So all the events that are happening previously, if you rewind my video, then all those time intervals will be considered as negative. So there is uh, no problem by choosing time as negative. So this is totally accepted. In fact, for distance time graph, it is accepted. For displacement time graph, it is accepted. In the same way, if I draw it like this, is it possible? Yes, of course, but for displacement time graph only. Okay, so displacement time graph, I'm drawing for 3 different cases. First, at rest, then it will be parallel to time axis, or it can just coincide with time axis, or if it is displacement time graph, it can be somewhere here. So I will draw it with different colors. If it is, if see, If I am choosing the reference point, just if reference point is just coinciding with the object uh, whose motion we are studying, then ST graph will be like this if it is at rest with respect to reference point. And if it has already some separation with reference point, then its graph will be this at stationary position only, rest position only. And third case, if with respect to our reference point, if it is in the negative direction, then this will be the its graph. Then comes the case of uniform motion, in which velocity remains constant. And if velocity is constant, then acceleration is zero. Remember this thing. Yeah, we generally explain uniform motion as in this type of motion, equal distance are covered in equal interval of time. So here it is. Actually, velocity is constant, acceleration is zero. So its graph will be like this, or this, or this. I mean, ultimately, it will be an ST graph with constant slope. That's important, with constant slope. Because slope of ST graph is equal to velocity. Remember that thing. Okay, another thing, another graph for constant acceleration. That is non-uniform motion, and it is taking place for constant acceleration. So constant acceleration, then slope will goes on increasing. So I hope it is very much clear that origin of graph can be, I mean, starting point of graph line can be anywhere with respect to a reference point where we have chosen the reference point. So it can be any of them, but constant acceleration, then its slope will continuously increase. See, this is how their slope is increasing. First slope is this, then this, then this, and then this. So slope is continuously increasing. So slope is increasing means velocity is increasing. Velocity increasing means there is an acceleration. Though it is again subjective term that by which way it will increase, but ultimately if there is an acceleration, slope will continuously increase. If there is constant acceleration, then it will increase like this. There can be variable acceleration. We can't draw a graph for it. Okay. Next, there is VT graph. So for VT graph at rest, it is an empty graph. There can be nothing because there is no velocity. Velocity is zero. What we can mark here. But if it is in uniform motion, then we can plot something. So either it can be this, or it can be that. Each time I'm drawing positive part bit upper and negative part bit lower, it is just in order to save the space and nothing more than that. It can be anywhere. Okay. Next, acceleration, constant acceleration. If it is moving with, oh sorry, if it is moving with constant acceleration. So if it is moving with constant acceleration, then there will be a constant slope either this way or this way or this way. So that shows constant acceleration. And remember, the slope of VT graph, slope, in fact, if I should write like this, slope of VT graph gives the value of acceleration. So remember, acceleration is rate of change of velocity, and also slope of VT graph is the measure of acceleration. Okay, so here there is no slope, so acceleration is 0. There is constant slope, so there is constant acceleration. Now acceleration time graph. There can be acceleration versus displacement graph, velocity versus displacement graph. We'll discuss about them later on in some other video, not in this video. So for rest position, when there is no velocity, there is no point to discuss about acceleration. That will be empty graph. In fact, for uniform motion, if there is no velocity, there is no acceleration. But for this case, for constant acceleration, and definitely there is uh, it must be positive acceleration, so there will be some positive value, but that is constant. So this is what the graphical representation tells us. And now the important thing here, see, in ST graph we can find only its slope, and any other thing is meaningless. But in VT graph, apart from its slope, we can also find area bounded by the graph and bounded between the graph line and time axis. So here that is a meaningful quantity, and that is displacement. See, uh, for VT graph, for ST graph, velocity is equal to slope of ST graph, and here acceleration is equal to slope of VT graph. And remember, in differentiation, that differentiation has a hidden meaning of slope also. So this is same as ds by dt, and this is same as dv by dt. Of course, delta s by delta t is also accepted, which we have already studied in class 9th. Okay, now another thing, the another outcome from this graph is S. We can find displacement through VT graph, and that is area below the VT graph bounded by time axis. Here it is. So that's it. Okay. And here also, if we find this, here we are not interested in its slope. Maybe in some of the cases we would require, but that is a secondary thing. Then we'll use some calculus and all, so don't worry about it. But one thing we can for sure find, and that is area under the graph, and that gives us change in velocity. Area below the graph. Uh, Bounded by time axis. Okay, so that's a different story. Now focus here, and especially this part. Now remember that if there is a VT graph like this, then it has a definite value of velocity. Let us suppose it is v, and if we want to find displacement up to this time t, then area below the graph, that gives us a rectangle, and its area will be vt. And as we are saying that this area is equal to displacement, so which is obvious result, displacement equal to velocity into time. So that is an obvious result. But that is for constant velocity. Now what if we have a case of variable velocity, I mean constant acceleration, variable velocity but with constant acceleration. Let us suppose graph is going like this. Then of course again what we can do, we can find the area of this rectangle and area of this triangle. So easy, nothing serious about this. We can easily find it by our ordinary mathematics. But what if this graph looks like this, or any other value, or any other form, like this, or like this? Now what we can do, I'll focus here. What we can do, we can divide this graph into small strips, and we can find uh, because they are almost trapezium, somewhere they are rectangle, and we can find their areas and we can add them all. But still there will be some error. So how can that error be resolved? That can be resolved if these stripes are of negligible thickness. How much negligible? Because each time in these portions we will have this kind of structure. But if we are dividing it into infinitesimal thickness element, means almost this thickness, as this line is this much thick, in fact less than that, then somewhere at some point you will be finding a very very thin, a very very narrow rectangle. So we can say that S is equal to sum of the areas. And how are we finding area? It has value V. At particular instant it is V, and its thickness is delta T. So we can find it like this. But to give a more accurate answer, more precise answer, we have to divide these rectangle into very very small regions like this much thin. In fact this thickness will go on decreasing. So if we somehow manage to get this much thin line where delta t is tends to 0, then this value is almost 0, then area is 0. So our ordinary mathematics can't work here. Then again Newton came with another idea, and he introduced integration v and replace delta t by dt. It will be called integration. This is the sign of integration. Actually it is a dropped letter, dropped alphabet from older English, it is stressed S, uh, or we can say biggest S. So there is a country I don't know in Ireland or Switzerland. Uh, so its capital is Belfast. So they'll write it like this. Just check it out in the internet. Maybe I would be wrong. So uh, okay, moving on. So they replace this sigma sign, which indicates summation, with this stressed S, which is now integration sign. So we'll call it integration of V with respect to dt. And now, once again, there is a entire list of formulae for this integration, but I'll stick to some of the formulae only, and there they are. If this v depends upon t as constant, if it is not depending upon t, depends upon t as t to the power n, depends upon t as t to the power some constant multiplied by t to the power n, or even zero, then how will integration go? So let me start from here. So S is equal to integration t to the power n. Actually, v is equal to t to the power n, so I am replacing it here, dt. So it will be equal to t to the power n plus 1 upon n plus 1 plus some constant. Why is it so? And I am because you need not to be confused with so with the constant. So it can be any constant. So I am just writing it as c here. Here it is. In fact, I should change this in constant. That is a constant of integration. It comes, I am writing it k. How come this? Actually, there is a whole mathematics is involved here. I can give its derivation in some other video. Here just it is a gift given by mathematics to physics, and we are just going to use it. Okay, now what about this? C t to the power n dt. So it will be c t to the power n dt, and now the same thing. So final answer will be c t to the power n plus 1 divided by n plus 1 plus some constant. Why this constant is coming again and again and again? So before that, I will explain this, but much before that, let t to the power 0, v is equal to t to the power 0, that is 1. So if we are integrating 1, remember this thing, this will come again and again and again. So t can be written as t to the power 0 dt. Now we'll follow this formula. So that will be t to the power 0 plus 1 upon 0 plus 1 plus some constant. So there it is, t plus k. We can directly say that dt is t plus k. What is this k? I'm explaining it here. S is equal to integration of 0 dt. Okay, now understand this thing. Before doing this thing, let me tell you, integration is just opposite to differentiation. And for the uh, for the proof of it, I'm going to differentiate this. So I'm differentiating it, d by dt of t to the power n plus 1 upon n plus 1 plus k. So d by dt of here, this will come out, and here it is t to the power n plus 1 and plus dk by dt, that will be 0 because it's a constant. Now if we differentiate it, the formula was 1 by n plus 1, because it is already, then power goes in front, n plus 1, and there is 1 deducted from the power, that will be cancelled, that will be cancelled, answer is t to the power n. So if we differentiate the result of integration, we will get the question for integration. Its answer, if we differentiate it, we get this. If we integrate it, we get this. So in the same way, this 0 has come from some kind of differentiation. So means whose differentiation is 0? The differentiation of constant. So it means integration of 0 is constant. And that is why in each time when we are integrating something, actually inevitably we are also integrating 0, and that 0 is always bringing us some constant. So how to deal with that constant? So for that, what we used to do, we whenever we integrate something, we put some limit, like again I will give the same situation, and let us suppose v here is equal to some constant time t to the power 2. Let us suppose some question like this comes. So this is c t to the power 2 dt, and let us suppose limit of integration is 1 to 2. Then c t to the power 2 plus 1 by 2 plus 1, and now I will put this bracket and I will write this limit here, just to indicate that still I'm working on this limit. So that will be c by 3 t to the power 3 limit 1 to 2. And now we will put the limit of integration, and for that we will replace this t by this 2, then put minus and this t by this 1, and that will be the answer. 7 by 3 c. This is how we are going to do that. People might ask, where have that constant gone? So if we consider that constant also, then after this integration, actually there is plus k, and when I am putting the limit, what will happen? Then t to the power, actually in the place of t, first I have to write 2, so it will be sorry, actually here c by 3, and then here there is plus k also, so it will be 2 to the power 3 plus k, and then minus 1 to the power 3 minus k. Actually that constant will be considered in both the cases, and that constant will will come with both the values. So once, because while applying the limit we have to put negative sign, so negative of this will cancel that constant part. So while dealing with limits we don't have to worry about the constant part, because it will come in both the cases. Let me give you another example. Let us suppose we have given this value that sorry, v is equal to 2t square, and we have to find uh, displacement between t equal to 1 second to 2 second. It will be quite easier for us to understand. So s is equal to integration v dt with limit 1 to 2. So s is equal to 2t square dt 1 to 2, and then s is equal to 2 is taken outside, t cube by 3 because of the formula, and plus some constant k within limit 1 to 2. Then t 3 by 3, oh sorry, we will put the limit 2 to the power 3, in the place of t we will replace 2 by 3 plus k. This entire thing by replacing t with 2, then minus, then again replace this t by 1. 1 cube by 3 minus k. Why minus? Because already it was like this, and then we will open the bracket, then it will become negative. So that constant part, whenever we will apply some limit, then that constant part will be eliminated. So if we are dealing with the limits, so most of time in class 11th we will be dealing with limits all the time, so you need not to worry about that constant that comes in integration. So this is how we are going to do it. So let me give you some of the problems based on this integration. So like this, you can try it of your own. Solve this. S equal to integration 0 to 5 and 2t minus, or plus will be better, easy calculation, t square dt. You can give a try to it. So here before ending this video, I will give you a brief idea of this chapter. So if we write types of motion, actually for linear motion only, and especially in one dimensional, uh, or maybe sometime two dimensional, but we are not considering the vibrational or any other kind of random motion. We are just focusing here. So it can be uniform, it can be non-uniform. Uniform motion, velocity is zero, velocity is constant, acceleration is 0. In non-uniform, there can be two conditions. First, in non-uniform, so velocity is variable. But there are two cases. Acceleration is constant and acceleration is variable. In such cases, we use this formula, velocity equal to displacement upon time. That's all. But here we use equations of motion, which I'm going to explain in next video, which are v equal to u plus at, s equal to ut plus, oh sorry, ut plus half at square, and v square equal to u square plus 2as. And if it is in variable, if acceleration is variable, then we are solely depend upon calculus. In fact, we can use calculus here and here also, but these formulae cannot be used for variable acceleration. Remember that. These formulae can be used, these equation of motion can be used for only constant acceleration. And some people can say that it is also used for